Hi friends, this is Parvati from OPRA Capstaki. Welcome to my channel. I need your support, so please subscribe, share and like my videos. Also, you can mention your valuable comments in the comment box. Today we are discussing here the next topic from pharmaceutics, emulsion, and also I included some of the calculation from APEC. Today we are starting the next file for the calculation. We are discussing here the APEC chapter 1, okay? And some other calculation videos I already done. You can check it remaining in that file, okay? Then one more thing, in the description box I mentioned one link is there that's mainly for the OPRA syllabus, OPRA exam syllabus. So whatever we want to concentrate the important topics, that's I mentioned here in the link, okay? You can check it that one, and I already done video for that one. The same slide I put it in the Google Drive, okay? Please check it for the syllabus, that link, okay? And today we are starting from the emulsion. In the first slide I mentioned here the common classification of the emulsion. We know about this one, mainly liquid emulsion and semi-solid types are coming. And again it's classified into as per the formulations, lotion, foam, liniment for the liquid. Semi-solids again classified into cream, ointment and gel. What are the common examples we want? Everybody know about that one. I just mentioned the examples here, common examples. You can check it. Not that much important, but we want to just understand. So that's why I mentioned here, okay? And the next slide I mentioned here, what is emulsion? Emulsion means it's a heterogeneous system of two immiscible phases. Two immiscible phases, the one phase is water and the other phase is oil. This is common definition. Everybody know about this one. And here actually it's coming liquid dispersion system. The emulsion is a liquid dispersion system. Okay, so two phases in emulsion are coming mainly, dispersed phase and the dispersion medium. What is the dispersed phase? Dispersed phase means the liquid droplet. The dispersed or internal discontinuous phase is known as the dispersed phase. This is the substance that is distributed in the form of small particle or droplets within another substance. This is called the dispersed phase. And the other liquid phase is dispersion medium or the external phase, or it's also known as continuous phase. This is the substance in which the dispersed phase is distributed. It acts as the continuous phase. And next point is emulsifying agent. The emulsifying agent, it promote and maintain the dispersion of liquid particles. That means it's producing the liquid particles dispersion in the system, okay? And the particle size of an emulsion droplet is coming mainly 0.1 to 100 microns. These highlighted points are important, so that's why I mentioned the sign of the important point, okay? Please note down in your book, and we can expect the questions based on that, okay? And the next slide I mentioned here, mainly the emulsion phase is coming two types of emulsion phases, oil in water and water in oil. That means in oil in water, the oleaginous dispersed phase and aqueous continuous phase. These are the mainly oil in water, two phases are coming for this one. And a common example is mentioned here, the milk, oil. In the milk, the oil is dispersed phase and water is the dispersion medium, okay? And in water and oil emulsion, the aqueous dispersed phase and oleaginous continuous phase is coming. That means the opposite of the oil in water, okay? And common example is the butter, the normal example. Butter in the water phase, it's coming as a dispersed phase, and oil is coming as the dispersion medium, okay? In this next slide I mentioned here, emulsion can be classified into several types based on the nature of the dispersed phase and the continuous phase. We know already, we studied about this one. Normally it's coming two phases in the emulsion, dispersed phase and continuous phase. As per that, we can classify the emulsion into oil and water emulsion, water and oil emulsion, and multiple emulsion, micro emulsion and nano emulsion. These are the important classifications. What are the definitions I mentioned here? Oil in water we already done in the previous slide. Oil droplets are dispersed in a continuous water phase is known as oil in water emulsion. The common example I already mentioned, milk and mayonnaise. These are the common example for oil in water emulsion. And the next classification is water in oil emulsion. That means the water droplets are dispersed in a continuous oil phase. Common example is butter and margarine. And the next one is multiple emulsion. Multiple emulsion means these are more complex and can be either water in water or oil in water in oil. This is known as the multiple emulsion. It's used in specialized applications such as controlled direct delivery systems is normally using the multiple emulsions. Okay. And the next classification is coming the microemulsion. Microemulsion means oil in water and water in oil formed spontaneously by agitating oil and water phases with surfactants. By the agitation it's forming normally the microemulsion. It's clear and thermodynamically stable emulsion is known as microemulsion, and it's a single phased and it's not true emulsion because it's very clear, not same as like the common normal emulsion. So that's why it's not a true emulsion. Okay, and the particle size of microemulsion is coming from 5 to 140 nanometer or the 100 angstrom to 600 angstrom. Okay. And the example I mentioned here, sodium lauryl sulfate, SLS, and potassium oleate are both commonly used as emulsifying agent. The most important emulsifying agents used in emulsion is SLS and potassium oleate. Okay. One of the important point, we can expect questions based on this. Okay, in the pharmaceutical industry where they help in the solubilization and stabilization of various drug compounds. Okay, and formulation mainly it's coming the hydrophilic substance surfactants to produce the transparent oil and water emulsion of oils, and the surfactants values in the HLB hydrophilic lipophilic balance in the scale it's coming 15 to 80. 18 is the HLB value, and it's most extensively used one. And applications for the microemulsion is more rapid and efficient oral absorption than solid dosage forms. So it increases the transdermal drug delivery. These are the main applications of microemulsion. Very important topic in this section. You want to thorough with these points. Okay. And the next classification is nanoemulsion. Nanoemulsion is similar in size with the microemulsion. We already studied about microemulsion. And the nanoemulsion is prepared by polymerization process. And it's used to solubilize the drugs, mainly the globulins and toxoids. These are the important points about nanoemulsions. And the next topic we are discussing here, preparation of emulsion. Preparation of emulsion, mainly the methods are coming in depending upon the type of emulsifying agent. So the various methods are wet gum or English method, dry gum or the continental method, bottle method or Forbes bottle method, and the last one is nascent soap method or in situ soap method. Okay. And the first method we are discussing here, the wet gum or English method. It's a primary emulsion of fixed oil, water and acacia in the ratio 4:2:1. So in this preparation, first mix the emulsifying agent with water to form a mucilage. Then gradually add the oil while triturating to form the primary emulsion. This method is known as the wet gum or English method. Okay. And the second method is dry gum or continental method. In this method, a primary emulsion of the fixed oil, water and acacia. In the ratio we are adding this agents are 4:2:1. In this method, mix the emulsifying agent. Normally using the emulsifying agent is acacia. So the acacia with oil in a dry mortar we are triturating, and then add water all at once and triturate vigorously until we are getting a creamy white primary emulsion forms. These are the important preparation method for dry gum or continental method. The definition for dry gum or continental method. Okay. In bottle method or Forbes bottle method, it's normally suitable for volatile oils or small quantities. Very important point. I forgot to highlight it, but the preparation method is very very important. Okay, so this method is normally suitable for volatile oil or small quantities. And place the oil and emulsifying agent in a bottle and then add water, then shake vigorously. We will get the emulsion form. In the ratio we are adding oil, water, acacia is 3:2:1 or 2:1:1. Okay, and in the next slide we are discussing the next and the last method is nascent soap method or in situ soap method. In this method, a soap is formed by mixing relatively equal volumes of an oil and an aqueous solution that contains a sufficient amount of alkali. The soap acts as the emulsifying agent. And in the nascent soap method, one of the important example is olive oil contains the oleic acid. In this one, we are adding the lime water, then it formed the calcium oleate. So we already studied its act as the emulsifying agent. The soap is act as the emulsifying agent. In the ratio we are adding the olive oil and the lime water is 50:50. Oil is 50 and the lime water is 50. Then we are getting the soap. And the addition of an acid, if you are adding an acid, it destroys the emulsifying soap and it causes the emulsion to separate. So that is the purpose. If we want to separate the emulsion, we want to add the acid. Okay, it can helps to destroy the emulsion. Okay, one of the important point we want to know about it, oral oil in water emulsion. In the oral oil in water emulsion, it's preserved by using alcohol of 12 to 15% based on the external phase volume. And in the primary emulsion, preserved it's using the preserving agent, the solid preservatives. So the solid preservatives dissolved in water, so we can preserve the primary emulsions. Okay, we can expect the questions based on that, mainly the alcohol. Okay, and the next slide we are discussing here the excipients. What is excipients? Excipients play a crucial role in the formulation of emulsions, ensuring stability and effectiveness of the emulsion. Okay, so important excipients are, the first one is preservatives. Main examples, the common examples are benzalkonium chloride and alcohol 12 to 15%. Antioxidants, we know about it, that one. The common examples are ascorbic acid, vitamin C, the citric acid, and ascorbyl palmitate, lecithin are the antioxidants. And viscosity enhancer, mainly using the common example is beeswax. Okay, and the next one, the important excipient is emulsifying agent. Emulsifying agent, the definition we already studied in the previous slide. What is the purpose of emulsifying agent? It promote and maintain the dispersion of liquid particles. That is the purpose of emulsifying agent we are adding in the emulsion. Okay, emulsifying agent is mainly classified into two types, natural and the synthetic or surfactants. Okay, for the natural emulsifying agent, the common example we know, the normal usually using emulsifying agent acacia, that is the common example for natural, and the rest of them are agar, tragagant, methyl cellulose, carboxymethyl cellulose, pectin, gelatin. These are the examples of natural. And the next second classification of the emulsifying agent is synthetic or surfactants. That's normally coming three types: anionic, cationic, and non-ionic. These are the important methods for the important examples for the synthetic surfactants. Okay, and in the next slide we are discussing here synthetic or surfactants. What are the important examples for that one? We already studied, these are mainly three types. The first one is anionic. Anionic example is sulfuric acid esters. In very important topic, I forgot to mention, but in the first slide I already mentioned important. So these slides are very important. We can expect questions based on this. Don't miss it. we want to thorough with this one. Okay, so synthetic or the surfactants, mainly the anionic example is sulfuric acid esters. Example in this category for the sulfuric acid esters, we already studied about SLS, sodium lauryl sulfate, one of the important example. And the second one is sulfonic acid derivatives, mainly the example is dioctyl sodium sulfosuccinate. And the soap forms mainly 4 types are coming: alkali soap, that means oil in water; metallic soap means water in oil; and monovalent soap is oil in water; and polyvalent soap, that is water in oil. You just read it, this one, what are the important soaps, but important is the examples are very very important. Okay, and one of the other important point is in the anionic surfactants, they have high pH and high HLB value. That means it's sensitive to the addition of acids and electrolytes. Okay, and the second one in the synthetic surfactants, synthetic or the surfactants is cationic. Cationic, typically oil in water emulsion, and the common example is benzalkonium chloride and cetrimide. Very very important, we want to thorough with examples in this section. Okay, and the next one and the last one is non-ionic in the synthetics or surfactants. Okay, so in the non-ionic, 2 types are coming, mainly spans and twins. Spans means sorbitol esters, and twins, that is polysorbates. So first we are discussing here the spans. Spans mainly water in oil emulsifying agent, and it's normally used as wetting agent. Main examples are the sorbitan monopalmitate and sorbitan monostearate. And then the polysorbates or the twins, that is oil in water emulsifying agent, that means the opposite of the sorbitan, that means spans. And the second point is it's used as detergents and solubilizing agents. Mainly in the detergents we are using the twins. Okay, and examples are macrogel, that's we already know, polyethylene glycol, and it's compatible with, and the next one is it's compatible with the tannic acid, ammonium salts, and phenol. Okay, these are the main important examples for the polysorbitates or the twins. Okay, and in the next slide we are discussing some of the important points. Cetostearyl alcohol, and we are adding the sodium lauryl sulfate because the sodium lauryl sulfate is anionic surfactant, so we will get the oil in water emulsion. Okay, and the cetostearyl alcohol, if we are adding the cetrimide, we will get it the cationic because the cetrimide is in the cationic category example. And the cetostearyl alcohol, if we are adding the cetomacrogel, we will get the non-ionic oil and water emulsion. So as per the examples we are getting, we already mentioned the preparations is everything based on the emulsifying agent. Okay, and the next important topic we are discussing here, the HLB, hydrophilic lipophilic balance. Hydrophilic lipophilic balance, HLB, is a numerical scale. It's used to measure the balance between the hydrophilic, that means water attracting, and lipophilic, that means oil attracting properties of surfactants or emulsifiers. This is known as the HLB value. HLB scale ranges mainly from 0 to 20. 0 means that is completely lipophilic. Lipophilic means oil loving. Okay, so what we can understand from this point, the HLB value is decreasing. If the value is 20, that means the HLB value is 20 means it's completely hydrophilic. Hydrophilic means that's water loving, so the HLB value is increasing. Okay, very very important. Okay, important point. Then the next point we are discussing here, mixing two emulsifiers with different HLB values can help achieve the desired HLB value for a specific emulsion formulation. So if the value is different, the emulsifier's value is different, we will get a specific emulsion formulation. Okay, the next slide I representing here the HLB value, what are the ranges for solubilizing agent, detergents, and oil in water emulsion, wetting agent and spreading agents, and so and so. Then what are the levels coming for hydrophilic, water dispersible, hydrophobic. This scale value ranges is important. Okay, so the first one I mentioned here, HLB less than 9 means water in oil emulsion. Okay, and if the HLB value is 9 to 11 means the emulsion is water in oil or oil in water, because that is the center of this one. Okay, both can come. And if the HLB value is greater than 11, the emulsion is oil in water, because the reason we know about that one, water loving, how much is the range is coming, and what is the lipophilic range is coming. So as per that we are discussing this one here. Okay, and the next point is, to prepare water in oil emulsion we use water in oil emulsifier. That means example is pans. Okay, we already studied about that one. If we want the water in oil emulsion, we want to add it to water in oil emulsifier. Okay, then non-oxynol, one of the important point, and we can expect questions based on this one in the caps or then the OPRA. Okay, non-oxynol means it's a surface active agents, and it's mainly the action for the non-oxynol is spermicidal action, one of the important action and one of the important use for this one. Okay, please thorough with this one. Then the next one is rose oil plus cetrimide. If we have combined rose oil with cetrimide 20%, so we can stabilization by agitation. If by agitation we can stabilize the emulsion. Okay, and the surface active agents is used in emulsion as emulsifying agent. What is the purpose of surface active agents? That's I mentioned for that point. Okay, and the next point is surface active agents in the tablets whatever we are adding. For what is the purpose of surface active agents adding in the tablet is it have to improve the dissolution and bioavailability. Mainly the common example is SLS, sodium lauryl sulfate. One of the important some of the important points I just mentioned in this slide. Please thorough with this one. We can expect questions based on that. Okay, and the HLB scale also you want to thorough it. And the next slide I mentioned here the uses of surfactants in pharmaceutical products. What are the uses for this one? The first point, first use is percutaneous absorption enhancers. It's used as enhancer. One of the important example is sodium lauryl sulfate. And the next use is cleansing agent. Example is it's used in cleansing agent in contact lenses solution. And the third use in the pharmaceutical products for the surfactants is therapeutic activity. Example, dialkyl sodium sulfur succinate, docusate, everybody know, and it is non-toxic and non-irritating, so it's used as emollient laxative to soften stools. One of the important use for the docusate. Okay, we know it's available as enema also. Okay, and opioid, in the opioid induced constipation mainly use this one. That means opioid induced constipation, one of the important opioid is morphine. So if the morphine is using, maybe the bowel movements can become very difficult. So in this case, if some patients is using the morphine, so in this patients we can use this one docusate. Okay, for the purpose of laxative. And some of the important hydrophilic lipophilic balance range I mentioned here as per the table from the CPR. You can just check it, that one also. Okay, sometimes maybe they can ask based on this one HLB value range questions also. Okay, so that's why I mentioned. And the next slide I mentioned here some of the important points so that's why I mentioned here not. So these are important points we are discussing here. The oil in water emulsion of chlorhexidine. That means the chlorhexidine, it's a cationic nature. So the emulsifying agent cetrimide, that is the cationic surfactant. Okay, so in the oil in water emulsion of chlorhexidine, if we want to prepare this chlorhexidine, we want to add the emulsifying agent cationic surfactant cetrimide. So we are using in this preparation the cationic surfactant is cetrimide. One of the important question we can expect in the caps also, or the OPRA. Okay, And the salicylic acid preparation, the salicylic acid ointments or creams, wool alcohol is used as the emulsifying agent because it helps to create a stable oil in water emulsion. So that's why the wool alcohol is used in salicylic acid preparation. Okay, the next point we are discussing here, the next topic, emulsion can become unstable due to several factors. Whatever the important factors become unstable for the emulsion. Okay, the first one is aggregation of globules. Aggregation of globules, what is that? When the internal or dispersed phase forms aggregates or clumps of globules, it can lead to instability. So the emulsion is unstable. And the second factor is concentration layer formation. That means these aggregates can form a concentrated layer of the dispersed phase which distributes the uniformity of the emulsion. Okay. And the third factor is phase separation. Phase separation, if all or part of the dispersed phase separate out and forms distinct layers, the emulsion breaks down. So it's also act as a unstable factors for the emulsion. Okay, and the next topic we are discussing here, stability problems of emulsion. What are the important stability problems? The first one is creaming. Creaming we already discussed previous slide, just I mentioned here also because for the definition I mentioned here. Okay, creaming means the dispersed phase rises to the top or sinks to the bottom due to density differences. Because of the density differences, it's forming like creaming. Okay, and what is that? It's a reversible process. That means we can reverse it, the creaming process. Okay, what we want to do is thoroughly shake it. Normal emulsion back till that we want to thoroughly shake it. Then rate of creaming calculated by the Stokes law. So the Stokes law is using for the rate of creaming. We already studied this one in the Stokes law. We already studied in the first slide, I think, in the solid dosage form. Okay, and the next one is coalescence. Coalescence means that is droplets merge to form the large droplets, eventually leading to phase separation. That is coalescence. This is also a reversible process. How we can reverse it? By adding surfactants. If we are adding the more surfactants, we can overcome this problem. Okay, and the third one is flocculation. Flocculation means the aggregation of droplets without breaking the protective stabilizing layer at the oil water interface. This is known as the flocculation. Okay, this is also a reversible process. How we can overcome this problem? By mechanical agitation and adding surfactants. Either one method we can use for reversible this process for the flocculation. Okay, and the next one is phase separation or cracking. From the heading we can identify phase separation means the dispersed phase separates completely from the continuous phase. It's also but this is not a reversible process, it's a irreversible process. Its causes of the main causes of the cracking are temperature changes, addition of extensive electrolytes, inadequate emulsifier, mechanical stress, aging. Aging means the emulsion can degrade, that is aging. Okay, these are the important causes of cracking. Okay, the next one is we are discussing here for the stability problems for the emulsion. In the last one is phase inversion. Phase inversion means the emulsion changes from oil in water to water in oil, that is, or vice versa. Okay, that means entirely change to the other one. Okay, so the main causes of the phase inversion is changes in the concentration of the emulsion. Okay, these are the important stability problems of emulsion, very important. Please thorough with this one. We can expect questions based on this topic, okay, in the CAPS or OPRA. Okay, and the next topic we are discussing, what is the stability of emulsion, how we can evaluate the stability of emulsion. Okay, phase separation, globule size, flow properties, the effect of stress on emulsion. From this we can evaluate the stability of emulsion. Okay, And the next point we are discussing, these are just important points, whatever I forgot to mention there. So wetting agent, what is wetting agent? The HLB value 7 to 9 that help in contact between solid and liquid. So that is the wetting agent action. And the example is dish soap aids in the contact between water and the solid, so the solid can be washed out. Whatever the normal purpose of this one, the example, through this example we are discussing the wetting agent. Okay, what is the purpose of wetting agent? And the next one is surfactant. We already studied that one. Surface active agents that reduce the surface tension, that is the purpose of surfactants. Main example we already studied that one. Sorbate and fatty acid esters are used in creams to decrease the surface tension between the two phases in the cream. These are the main important points whatever I forgot to mention there, and we can expect some of the questions based on this one also. Okay, from the next slide, sorry, one more slide is there. Next slide I mentioned the other point is detergent. What is detergent? HLB values 13 to 16 is normally coming for detergent, and the purpose of the detergent is reduce the surface tension and aid in wetting. Okay, what is the emulsification? Emulsification means interfacial tension decreases and its repellent forces decreases, and also attraction for own molecules decreases. These are emulsification normally what are happening there. Okay, in the emulsification. And the next topic is the next point is emulsifying agent. Emulsifying agent we already studied the HLB value water and oil. If the water and oil is the emulsion 3 to 6, and if oil and water is the emulsion 8 to 18. So the purpose of emulsifying agent is minimize the surface energy. The common example, the commonly using emulsifying agent example is SLS, and in the emulsion, so the two phases is in an emulsion do not separate. That is the purpose of this one, emulsifying agent. Okay, these are the important topics we want to know about the emulsion form. This much is enough. If you want the detailed description, you can check in the CPR also very condensed form they mentioned on there. Okay, and from the next slide we are discussing here the APEC calculations. The chapter 1 is we are discussing here coming pharmaceutics topics theory classes. Also we will include the remaining chapters from the APEC, so please check it. The description also I mentioned there, and what are the important steps we are discussing here also I mentioned. Okay, today I am just wind up here. Thanks to support everybody, and don't forget to like, share and comment here for my videos. And today I am just wind up. Thank you.